Let's use this today.
It's the Power Tronic EF3 from Race Dynamics, right? The current version is the 4 and it's smartphone compatible.
Tell me what it can do.
It can control fuel injection, ignition timing, move the lev limiter, add an aftermarket quick shifter, and more. Physical channel, buy in Japan.
I've only been using the lev movement, fuel control, and ignition timing control. So I'll focus on these 3 since I explain it.
Understood, Master.
What are the precautions for installation?
First, if you connect it to a computer, install the USB driver first. Next, install the Tune software for settings. Second, there are recommended maps for each vehicle model on the website, so download those.
In my case, I had an old map, and when I used it, I couldn't move the lev limiter. It worked fine after I switched to the latest version.
Did you attach a unit to the motorbike yourself?
I had a connector that just wouldn't come off. So I asked the motorbike shop to remove it, and they did it right away. It's just a matter of swapping the connectors, so I could have done it myself. But I consulted with them beforehand and made it as easy as possible. So it was inexpensive.
Are there any other points to be aware of?
My bike, a KTM Duke 250, had a key cylinder that was hard to remove. There are also some areas that are difficult to remove depending on the vehicle model. So it's a good idea to check in advance.
Yes, Master.
Okay, let's start with the lev movement.
Yes, Master.
First, connect the unit to USB and then launch your Tune. Use the connect button in the upper right to connect. Use file open in the upper left to open the map. You downloaded from the website.
Yes, Master.
At this point, it's not yet reflected on the unit. Let's make the lev changes from here.
Yes, Master.
From the config tab, you can set the limiter at RPM to your preferred RPM. I started with 12,000 RPM, and now it's at 13,000 RPM.
How do you decide the limiter value?
To be honest, it's trial and error. I've seen videos of the 250 Duke running at 14,000 RPM, and on the 390 Duke, it's lower. And there are videos where the engine brakes. In my case, I occasionally hit 12,000 RPM, and I didn't like the limiter kicking in there. So I set it to 13,000 RPM, but honestly, it's quite hard on the engine.
Won't the engine brake?
If it's tuned for racing, you should activate the lev sooner, and for street use, the output first decreases, and it no longer rotates at high RPM. It's not fun if the rotation is too high and there's no power. The 250 Duke is enjoyable up to 12,000 RPM.
I understood it. So revving too high won't give more power.
If you want more power, choose a bike with more power. This adjustment is just for a smoother ride.
It's about adjusting for your own bike.
Exactly, for a more enjoyable ride. Both in terms of fuel and ignition timing. Not for going faster.
Yes, Master.
When I ride on the open road, I use less intake and exhaust air, and lean fuel to improve fuel economy and environmental performance. On my bike, it is considered to be good for the bike if it is minus 8%.
Yes, Master. So you are changing the intake, exhaust, and fuel on your bike?
Yes, I have lightly changed about 50,000 yen, including Power Tronic EF3.
The Master's bike can take in a lot of air and emit a lot of exhaust gas, can't it?
Yes, I don't know how much of it is, so I have to check it as I go. We'll do it that way. I'll start by determining the fuel. Before we go any further, let me warn you that the fuel is too rich and may activate the auto sensor. Rex, and the engine failure light comes on. So it's best to do it in short order as it is.
You mean you test the Master at 6,000 RPM or more?
In the case of my bike, if I drive it slowly, for more than an hour, the auto sensor reacts. And I know how to turn off the malfunction light. So I do the whole thing, but if you are worried, you can just do it in the high RPM range.
Why is it okay to just do it in the high RPM range?
Because the manufacturer's fuel maps are excellent. and they do the whole -8% or so from there. So all I need to know is how much it's being reduced.
Yes, Master. First we measure the amount that is being reduced overall.
Then I want you to map the entire fuel map at +10%, +20%, +30%, and +40%.
Yes, Master. It's done. Why are you changing it by 10% each?
Because the performance of the current injection system has improved so much that even if there is a slight difference, you can't really feel it. If you haven't changed the intake and exhaust, just give me 5%, 10%, 15%, 20%, and so on.
Yes, Master. How do you know if it's rich or lean?
If it's too rich or too lean, the engine won't run as good as it should. If it is too lean, you will hear a popping sound coming from the muffler. And if it is too rich, you will not be able to get the engine revving.
Master, I get the general idea, but how do you know if it's rich or lean?
When it's rich, the engine tends to generate more power. Acceleration is jerky when fuel is rich. And if you run it too rich, the auto sensor will work and the check engine light will come on to tell you.
Conversely, if it's too lean, there's less vibration and the curves don't feel as powerful, and that the engine revs up more quickly.
Ultimately, it's going to be whichever I prefer. But I wouldn't know the difference between the two by 5%.
In that case, which would you choose?
The one with less fuel. I don't need to waste fuel. And the auto sensor is more responsive when it's rich. I'll choose the thinnest one I can find to my liking.
Yes, Master. Final choice is lean.
Next, try making it at 20%, 25%, 30%, 35%.
Yes, Master. Since I can't set 35%, can I make it 36%?
No problem. I've been on it, 25%, 30%, either way is fine.
Then I guess I'll settle for the lean one, 25%.
That's good enough. Now, it's time for fuel adjustments where we don't need power.
Where do we not need power?
Below 5,500 RPM. We mostly want just enough power to maintain speed while riding with the flow of traffic. In terms of throttle position, it's below 50%. Especially below 20, you hardly need any power.
So, in this area, right?
Exactly. Reduce it gradually by about 2 at a time.
Alright, Master. Is this okay?
No problem. If we don't do this, the engine warning light will come on. If it still comes on at 10, we'll have to lower it even further.
Got it, Master. Any other adjustments needed?
That's about it. Just one more thing. Handling the power shortage at 4,500 RPM. I compensate for it with ignition timing. So I'm not too concerned, but it might be worth increasing the fuel slightly. Also, create a map with about 5% less fuel for the other one.
Why is that?
If the air filter gets dirty and you're riding a mountain road, there might not be enough air, and the gasoline will become richer. It's a precaution. Well, I probably won't use it, though.
Understood, Master. It's done.
Alright, let's go over it.
We'll increase the amount of gasoline by 10%.
Yes.
Next, we'll adjust the area between the two good maps by 5% each. And if there are two options, we'll choose the lower one.
Yes.
As the final adjustment, we gradually reduce the fuel for throttle openings below. To prevent the engine warning light from coming on, gradually lower the throttle position from halfway down.
Yes.
Finally, you have the option to add or reduce fuel to your liking. I've created two maps, so you have a 5% leaner fuel map for use in thin air at higher altitudes.
Yes. Well done. Adjusting the ignition timing can potentially destroy the engine. So be especially cautious. I can't take responsibility if it breaks when done my way. It's your responsibility if you decide to adjust the ignition timing.
It's just one method. It may not be suitable for your bike, so proceed with caution. Where should I start then?
Start with inspecting the machine. What we're discussing now assumes that the air filter is clean. the gasoline is fresh, and the engine oil is in good condition. In other words, the manufacturer delayed the timing to make it work even in bad conditions.
So they make it more better perform well in good conditions.
Exactly. Once you've set the timing, you need to keep the bike in good condition at all times, or it will break.
I understand. If I decide to adjust the ignition timing, I'll make sure the bike is in good condition. If I'm not going to ride it for a while, I'll revert the timing.
Okay, now check the ROS value. ROS is the gasoline's octane rating.
The Master's bike is specified for ROS 95. In Japan, we have regular ROS 90 and high-octane ROS 100.
Right. We can't use the lower one, so we'll go with ROS 100. What I'm about to say is just a rumor, so don't take it as fact. It's said that the manufacturer delayed the timing by 5. For when conditions are bad. Engine for ROS 90 and using ROS 90 gasoline, you can go up to 5. For engines designed for ROS 90 but using ROS 100, you can go up to 10. But of course, if it's in bad condition, the engine will break.
I understand it. So it's just a possibility that you can use from +5 to +10. It's just a rumor.
Exactly. It's just a possibility. Depending on the bike's condition, +5 might break it. Now, about my bike.
The Master's bike is specified for ROS 95, but you're using ROS 100 gasoline.
Yes, there's a possibility of going up to +7 or +8.
Alright, from +5 to +8, I'll create the map. How should I set the ignition timing?
It doesn't work well whether it's set low or high. You'll have to try it while riding. If the timing advances too much, it can break suddenly. So if there's not much difference, choose the lower one.
Alright, I'll make the adjustments to the data.
You won't be able to tell from the outside, so skip the riding scenes.
Master, how was it?
+6 feels a bit lacking. +8 makes it harder to rev up at low and high RPMs. +8 seems to be the limit. However, there's a power dip between 4,000 and 5,000 RPM.
So for your bike, +8 is the maximum.
Yes, now let's proceed with the final adjustments.
Alright, Master.
The +7 timing works well throughout the entire RPM range. +8 starts from where the torque dip begins at 4,500 RPM. From 6,500 to 8,500 RPM, it's +7, and above 9,000 RPM. We don't need much advance, so it's +6.
Yes, Master.
Even though the ignition timing at +8 has been fine for a few thousand kilometers, I can't be sure it'll be fine in the future. Since it produces more power, it might wear out quickly.
Adjustments are at your own risk. Be careful not to get injured. Thank you so much for watching. Please subscribe to my channel. If you like this video, don't forget to like it. I'll see you in the next video.